Hi folks, welcome back to Math with Captain Rod. I'm making this video here to help you out with Module 14.4, the application problems here. And we're going to start by taking a look at this one. It's the second one down on the page if you have your handout. And it says 5 times an integer plus 3 times the square of an integer is 22. So the first thing we're going to do is define a variable here. Let's say, how about let x equal the integer that we're looking for. And now the next step is to take a look at this sentence here and try to translate it into a mathematical equation. So it says 5 times an integer, so that would be 5x, plus 3 times the square of the integer, so that would be plus 3 times x squared. Now, not square root, because it says the square, not square root. All right, so of the integer is 22. So we got 5 times the integer plus 3 times the square of the integer is equal to 22. So there's the mathematical equation that comes from this sentence here. And now what we need to do is solve that for x. Well, let's see. Noticing that it's quadratic, why don't we kind of rearrange it? 3x squared plus 5x. And what we do with the 22 here kind of depends on how we're going to try to solve it. I'm going to go ahead and just think about maybe factoring or quadratic formula, which means we want a 0 over here, so we're going to have to move that to the left. And let's see. Maybe we try to factor it. If it factors, it's probably going to be 3x x. And let's see, factors of 22, let's see, are 11 and 2. And putting an 11 here would give us a 33. That's not very hopeful. Putting a 2 here and an 11, let's see, 6. We put a 2 here. Try that again. 2, 6, and 11. And they differ by 5, so that's got some promise to it. And so let's try it with the 11 here. And now plus and minuses, noticing that this is plus and then minus. I think that'll work. 3x squared minus 6x plus 11x. There's my plus 5x minus 22 equals 0. So there's the correct factorization of this. Also, by the way, you could use the quadratic formula with a being 3, b being 5, c being minus 22. That would work perfectly fine. All right, so moving along with our solution. So now we have the product of two things equals 0. One possibility is 3x plus 11 is equal to 0, in which case 3x would equal minus 11 and x would equal minus 11 thirds. And one thing to notice is this is not an integer, so this is not the solution that we're looking for, and that's perfectly fine. We'll move over here and take a look at this guy. All right, x minus 2 could equal 0, and we would solve this by adding 2 to both sides. And that kind of looks like our integer there. And I'm going to go ahead and kind of check it against our original equation here. So 5 times that integer plus 3 times the integer squared. Let's see, this would be 10 plus 4 times 3 is 12, and we get 22. Okay. So there's one of the examples on this page, and I think what I'll do here, I'm going to try to put a couple of them on the same video, and I think what I'll do is pause this while I set up the next one. All right, folks, I'm back, and we're going to take a look at the third problem down here on your Module 14.4 applications section. And it says, I took a little time here to type it out, an old pump requires 9 hours longer to empty a pool than a new one. With both pumps running, the pool can be emptied in 6 hours. And I shorthanded this, but find the time for the new pump to empty that same pool. Okay, so the first thing we want to do is define a variable. We might do something like, how about let t equal time for new pump to empty pool. Oops. Now, so I've got an old one and a new one. And I've decided that, or I've defined t as the time for our new pump, and it says an old pump requires 9 hours longer to empty the pool. So if I've called this one t, then the time over here is going to be t plus 9. Now, let's talk rates. And I'll write this across here. So if the new pump requires, t hours to complete the task or empty the pool, then the rate is 1 over t. And if the old pump requires them t plus 9 hours, then the rate that for this to drain the pool would be 1 over t plus 9. And it's just like, again, I want to talk about where I'm, how am I getting from here to here. So imagine, for example, that the pump can drain that pool in, say, 4 hours. Then the rate would be 1/4 pool per hour. Okay. If it takes 4 hours for a pump to drain the pool, then it can drain 1/4 of it in an hour. So that's where those rates are coming from. All right, so now let's see rest of the problem here. I've got my rates for the old and the new. Now, if they're working together, the new rate is the sum of the two. And it says it can be emptied in 6 hours. So working together, I'll put this here together. The time is 6 hours, so the rate is 1/6 pool per hour. Now I can just kind of put these together. So the rate working together is the sum of these two things, and that's going to equal our new rate. So we have an equation here now that we can solve for t. Now notice that we've got a t plus 9 in the bottom here, and a t in the bottom here, and a 6 in the bottom here. So what I'm going to do is I'm going to take this equation and I'm going to clear out all the fractions. If we multiply by t plus 9, that will kill this guy, basically, or not kill, but reduce it. If we multiply by t, that will reduce this down, get rid of the fractions. And to get rid of this fraction, we'll have to multiply by 6. So, now, what you need to realize now is that this thing needs to hit all of these. This, this, and this. And if I kind of put it over here temporarily for a minute, when we do this multiplication, notice that the t plus 9s will cancel. When we do this multiplication, notice that the t's will cancel. When we do this multiplication, notice that the 6's will cancel. So I'm going to go ahead now and do those products. So again, this product right here, keep it in mind, the t plus 9s will cancel. So we're going to be left with just the t and the 6. So I'm going to go ahead and write 6t plus. And again, remember, when we do this product, the t is going to cancel. So we're going to be left with 6 times t plus 9. And when we do this product, the 6's will cancel. So equals t plus 9 times t. So what we have now is an equation here that we need to solve for t. So let's see, 6t plus, this product is going to be 6t plus 54 by the time we distribute that, equals, over on the right we've got this t squared plus 9t. Okay, and I need a little bit of room here, so I think what I'll do, we'll just shrink this down a little bit, raise this up a little bit. All right, pick up on this right here. It's quadratic, so I'm going to put everything on the left, and I'm going to want, a 0 on the right. So I would have to subtract t squared from both sides. I'm going to put this all the way over here, minus t squared. And then we have 6t, and 6t is 12t. Subtract 9 more, that's going to give us plus 3t. And then we have plus 54. I think I've done that right, but I want to double check. So subtract the t squared. There's that term. 6 and 6t is 12t. Then we would have to subtract 9t, so that's going to give us 3t. And then plus 54. Okay, I think we're good. Now I'm going to go ahead, maybe try to factor this. I don't like to try to factor when that thing's negative. Let's do this. Let's run through this and multiply everything by -1. Maybe it'll factor, maybe it won't. Let's see, 54. Let's think about different numbers there. I think that's 9 times 6. And I'm noticing a 3 here, so that shows a lot of promise. So let's see, how about t minus something, t plus something. Noticing that this is -3. I think that's the correct factorization. So let's see, t squared, that looks good. Plus 6t minus 9t, there's my -3t, minus 54. All right, we're looking good here. Now, one possibility is that the t plus 6 equals 0, in which case t would be -6. But t is a time. This is not one. This thing is not going to work for us because generally speaking times will be positive. Other possibility is that t minus 9 equals 0, in which case t would equal 9 hours. So I think what we're looking at here is that let's see, t is the time for the new pump to empty the pool. It's looking like 9 hours. And then the old pump would be 9 hours longer than that, 18 hours. Okay, I think I'm going to stop this video now at 11 minutes. I hope that this helps. The key here is really read the sentences carefully in these application problems. Very clearly define a variable, and then try to write some sort of algebraic equation that describes the wording of the problem, which I did here. All right, have a great day.